Hey guys, what's up? Today I'm here to talk to you today about train networks. So more like the bigger picture, what you're going to do and why you should use them, and just the types of networks that you can have. There are three main types of networks you can have in Satisfactory, being unidirectional, bidirectional, and push and pull. Now, you'd think those, for me, those are a little hard because, see this railway right here? There's two railways, or the two rails. I guess they are railways individually. This is a unidirectional rail. Now, it is called this because each railway on each side has its own direction. It is dedicated to one direction, which is usually what block signals help for since they are one directional. They are unidirectional block signals. They only go in one direction. So it makes sense why these ones are unidirectional because they only serve one lane of traffic or one direction of traffic on each side. Now, bidirectional is not the same. Bidirectional, okay, let's look at these individual. Instead of looking at both of these railways, let's look at only one. So let's look at this right side right here. So this right side, for unidirectional railways, this is going to be my forward end because I'm American and I guess I just put it on the right side. And because these, if you put them on the other side, they clip together like that. And I don't like that. I like being able to put my railways close together without having to have those signals clipping. I've seen people do it with left-sided railways. It doesn't matter how you do it. I don't care. Do whatever you want, right? So, let's look at these individual rail segments. This being a unidirectional railway, ignore this one. We're just going to look at this. This one only goes one direction. You can only go forward. There's no trains 180 degrees going backwards. They are all, if you ever see them, they're always going to be passing towards my right. The train tracks, or the trains on the other segment, are going the other way because I need another direction to serve both lanes of traffic, which makes sense. Now, a bidirectional railway, if we're looking at only one railway at a time, would essentially be this railway would be serving both directions of traffic instead of just one. So if I was a train, I could be going this way, or I could be going this way, which obviously leads to some problems and also leads to less traffic, hence why I'm not using them. Hence, I literally cannot make an example in my world. I guess this big, world sort of train route that goes everywhere, it goes all the way over here and then all the way over here. That's a bidirectional railway, but I've only ever served one lane of traffic. It's a closed loop system, which I'll talk about later, so it doesn't need to be bidirectional. Technically, it's unidirectional, but for demonstrative purposes, that is a bidirectional railway. So push and pull networks are next, but first I'm going to just review quickly. So you've got unidirectional railways, where trains can only go one direction, and you've got bidirectional railways, where trains can go both directions. A push and pull network is classified as a bidirectional railway, but I keep it in its own separate category, because on a push and pull network, you can only have one train going at a time. So essentially how this works is it's two locomotives facing away from each other, and I will prove just real quick, if I don't have them facing away from each other, if I have them facing towards each other, this system does not work. The Satisfactory, it classifies them as separate locomotives, it classifies them as the same locomotive. It just will not, it says station unreachable, it said because it just will not, transition those locomotives to do that. So let me just delete these and replace them. In the correct orientation, you can have as many freight cars as you want, but for, again, demonstrative purposes, there's only one. Yep, that's kind of it. Push and pull networks. So, to get the best out of a system, you could have one station right there, one station right there, and one station right here, and then you'd connect up this station and this station. You'd make a triangle, essentially, so that at any given point, this train could go to here, and then it could go back and forth between these two, and this one could go back and forth between these two. And you could have a third train, but I wouldn't, mostly because that would probably reduce traffic by a bunch. But the main reason why I had to make this little jig here is because these aren't very useful in worlds. I was considering using one to transport nuclear waste, but I just dropped it off over there instead. You can see that big yellow building over there. I was considering using one of these to transport it pretty far, but I decided not. So that's a push and pull network. Now for railroad crossings, you can see, I guess for like intersections, this is a unique one actually in my world. There's only one of these because it takes up so much space. Because you have to have so many segments. You have to have 16 segments to connect each of these to their own thing. So this is a roundabout. You can see them in real life. They look pretty similar to this. This one has a station at one end, and then essentially an inlet outlet. So we got unidirectional, unidirectional, and this whole thing is unidirectional. This roundabout is a unidirectional roundabout, mainly the fact that you can only go around that right side. Again, more of an American thing, but, well, I guess a lot of the world does it. It's more the Brits who like to take their roundabout the other way. So that's one form of crossing. Now I'm gonna snap, and we'll be there. So this is another type of intersection that you'll see scattered about my world. This is probably the most useful intersection that you can make. And a roundabout essentially is a simpler version of this, but with just like more complexity. So a roundabout is just this, but it's round, and you can exit. You can go all the way around the roundabout, or you can exit at right here, enter right here, exit right here, enter right here. It's this, but it's like more space inefficient. So we use these for the most part. Now these have 3 inlets, 3 exits, and you place a path signal on all the inlets and a block signal on the exits. That's how you make these. It's pretty simple. You just connect. So this one would have right, left, right, left. Then you've got straight left, then you've got straight right, straight right. Pretty simple. This is the next type of intersection I will show you. And essentially, this is nothing like those previous ones, but this one's a little harder to make. So essentially, what I have here is the trains come in this right side, and they go around through the station. They stop at the station. Well, one of them does. Some of them just go straight around because it's more efficient. But there's one that stops here, and it goes around, and it goes through these two to the other side and around. Now, why I did this is because I needed a way to get to the other side of the tracks without going over, and I didn't want to go over. And also, I wanted to demonstrate this and have a real-world example of how to use this, because it helps if you guys have more examples of how to use it. This one does not use any path signals because there's no path for this train to take. It has to go straight ahead. There's no way it could turn left or right. It just, this intersection is essentially, there's 3 specific routes. For the previous one over there, or if you want to go up there, essentially you can choose your own routing. If you're at one of the inlets, you have 2 directions you could go. For this one, all of them can only go one direction. It's just a way for me to consolidate that intersection and essentially make a safe crossing for this what I'm going to call goose train right now. It's like a goose with a bunch of little ducklings or gooselings, and they just cross and merge on traffic, which geese don't really do in real life. But anyways, this is made for exclusively for crossing purposes and merging. You don't have to merge, but this one is for crossing without having to go over or under. That's what scenario you'd use this in. I would recommend using this version. And the reason you don't have to use, well, I already told you why you don't have to use any path signals, is because there's no other paths. It's just that one path. Path signals I would use for 3 paths, or 2. 2 paths or 3, 2 or 3. But this one, 3 is the maximum, by the way. So there's only 2 out of the 3 scenarios you'd use path signals in. This one is a safe bet. There's only one way, so you can use block signals. Also, important note, switches don't do anything. They're cosmetic. They do something when you're in manual driving, but for automatic trains, they do nothing. They're just cosmetic. You cannot delete them. As much as you try, they do not delete. And yeah, that's kind of that. What else? Closed loop networks. I referenced those earlier. Essentially what a closed loop network is, for example, this train is running on a closed loop network. What does that mean? I'm pretty sure you can infer by the name, but so let's say this train comes through here, it goes around, goes here, comes back, goes here. So now essentially we went from going this way, we've done a 180 that way. And over there, the train goes to the warehouse, does another 180, comes back, and completes the loop right here. So all you need to do for a closed loop network is have a train essentially going in a circle. It just has to do 2 sets of 180s to make a 360, and it needs to get back to where it is via that. There's really only a closed loop. There's 3 types of, like, that kind of network. There's closed loops, there's, like, bow ties, and the push and pull. The push and pull I already referenced earlier. The bow ties, they're like these, except they would use bidirectional railways instead of unidirectional railways. So what that would look like is instead of, it wouldn't have to cross over, it would just merge into it. And it would either wait for a train to come, or if it's by itself, it would just keep going. So it would make 2 sets of loops at either side, merging into one main track instead of 2, if that makes sense. A push and pull, you already know. And a closed loop, I just explained. What else do we have? That's kind of it. If you guys liked the video, please leave a comment saying what I did well. And actually, it would help me if you say what I didn't do as well. You don't gotta be mean about it. Just constructive criticism works perfectly. And if you are mean about it, cool. I don't care. I'll take the feedback because I'm a growing channel and I kind of need it. Thank you guys so much for watching, and that will be the outro that I cannot remember. Thank you so much.